Hey guys, welcome back. In this video, I'm going to show you how to use rectangles to estimate the area below a curve. So, I have this curve here, and I'm going to say that this curve is the function x squared plus 2. Okay? I know I didn't draw it perfectly, but that's okay. I'm going to use 5 rectangles in this example to estimate the area below the curve. I basically want this here. Let's say this is the number 2. Okay? I want the area from 0 to 2. And I want to make 5 rectangles. This looks more like 25 rectangles. This actually looks more like 100, maybe even 1,000. What you guys will see is that if you use a lot of rectangles, you'll get a better approximation. But in this video, I'm only going to show you how to find the approximation with 5. Okay, so I need to go back here. This is fine. I'll keep this. So this is what I'm looking for. Okay, so I'm going to build 5 rectangles. So the first thing is, how do we split up the rectangles? Well, you find the distance from here to here. So that's 2. And then you split it and you divide it by how many rectangles you want. Since you want 5, you're going to divide this by 5. Okay, so from 0 to 2 is 2, and then divided by 5. So basically it's b minus a over n. Now, this is 0, which is our starting point. This is 2/5, 4/5, 6/5, 8/5, 10/5. Okay, 10/5 is 2. So what do? Well, there's 2 types of rectangles that we're going to do. We're going to do an over approximation and an under approximation. We're going to use a left Riemann sum and a right Riemann sum. So what we're going to do is we're going to make this here. I'm going to make an L. Now here, I'm going to make an L. You guys see what the L is? I'm going to make an L. Once you do that, this is what you do. You go to the L and you go and make sure you hit the other rectangle. Okay? So when you do that, you're going to have some area left over. So that area is left over, that area is left over, that area, that area, that area. So this is going to actually be an under approximation. But 5 rectangles does a great job at capturing a lot of the area, and it's only an estimation. So what is the area of a rectangle? Well, it's going to be base times height, or length times width. The width of each piece is 2/5. So from here to here is 2/5. From here to here is 2/5. 2/5. Right? So it's from here to here is 2/5. 2/5. 2/5. So this part is 2/5, 2/5, 2/5, 2/5. So the width stays consistent with 2/5. However, the height is different each time. The height is this, 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 and this. Okay? We're not going to use the last one. So the height in this case is this. So make your L's for left. Now, the height, when it's 0, you're going to get a height of 2. When it's 2/5, you're going to get a height of 2/5 squared plus 2. Okay? So when the height is 4/5, you're going to get 4/5 squared plus 2. Okay, so let's take a look at what that looks like. I made this chart here. I said 0. Okay. I said 0. I don't know why it keeps erasing. I said 0, take 3. So what happens when you put 0 in here? 0 squared is 0 plus 2 is 2. What happens when you put 2/5 here? 2/5 squared is 4/5. 4/25 plus 2. 4/5, you get 16/25 plus 2. 6/5 and 8/5. Here are our 5 rectangles, okay? Now, these are your y values or your height. Okay, and I did that here for you. 120 25ths plus 10. Why? Because 2, 4, 6, 8, 10. And I added, when 4, 16 is 20, 20 and 36 is 56, 56 and 64 is 120. So these are just your height. Remember, you have to multiply each one of these by the width, which is 2/5. So this is 14.8 times 2/5, and your approximation is 5.92. So the left-handed approximation is 5.92. Left-handed means that you're going to use the left points. Now I'm going to show you what it looks like using a right. So let me see if I can just quickly draw this. I'm going to say that this is 2, okay? 0, 2/5, 4/5, 6/5, 8/5, and then we got to go up a little bit, and here's 10/5. Now we're going to do the right side. The right side is going to be an over approximation. So instead of making an L, I'm going to make a backwards L. And now I'm leaving out the first point, but I'm including the last point. So how do I draw these rectangles then? Well, you can make it come out here, and it should hit this. Make it come out here, and it should hit this. Make it come out here, and it should hit this. Okay? And then here's 1, 2, 3, 4, so we just need one more. As you guys can see, there's going to be more area than we need. So this is going to be an over approximation. So how do we do that? How do we estimate this? We need width times length, or base times height. The height that we're putting in is 2/5, 4/5, 6/5, 8/5, and then 10/5, which is 2. So I did that for you guys here. So the area, well, is going to be f of x, which is all of this here, right? So let's see, 2, 4, 6, 8, 10. 4 and 16 is 20. 56, 120, 220 25ths. So that's going to be 18.8. Now, that's just the height. You have to multiply each term by 2/5, and now that's going to give me 7.52. So what we did was we found an under approximation and an over approximation by using what they call inscribed rectangles and circumscribed rectangles, okay? This is an over, this is an under, this is a left, this is a right. So my actual area has to be somewhere between 5.92 and 7.52. So if your teacher already showed you how to do definite integrals, you'll see the actual area, 0 to 2, x squared plus 2 dx becomes x to the third over 3 plus 2x. Plug in the 2, plug in the 0, you get 20/3, which is 6.67. So 6.67 is the exact. 5.92 and 7.52 is our approximation. And the reason why they were that far away from 6.67 was because we only used 5 rectangles. If you use 10 rectangles, then you will see the approximation gets better and better. So I hope this was amazing and helpful and all that stuff. If you use infinite rectangles, guess what you do? These are all rectangles. If you use all of these rectangles and there's infinite amount, that's basically finding the exact area. But if you use 10 rectangles, then you're going to be using very skinny, so the approximation will be much better than 5, and so on. So what do we do one more time? You make your L, and you make your backwards L. One is for left, one is for right. And then that's pretty much how you do these inscribed and circumscribed left-handed, right-handed Riemann signs.